Hello students, I am Anamika and in this video we are going to discuss orthogonal matrix, and in previous video we have discussed transpose over matrix. So what is an orthogonal matrix? An orthogonal matrix is a matrix whose inverse is equal to its transpose, and in previous classes we have discussed that we will denote the transpose of a matrix by ADRE. So what will be an orthogonal matrix? If the transpose of a matrix is equal to the inverse of that matrix, then we will say that matrix will be in orthogonal matrix. That is, that matrix is an orthogonal matrix. Or if A into A transpose is equal to 1, we will say that the matrix A is orthogonal matrix. So before that we should know how to find inverse of a matrix. So for a 2 by 2 matrix, that is, I have taken this example, that is A, B, C, D. So if we are asked to find the inverse of that matrix, we will just use this formula, that is A inverse is equal to 1 by AD minus BC, and just interchange A and D, that is put D in the first place and put A in the last place. And here in place of B we will write minus B, in place of C we will write minus C. So let's take some example. So A is equal to 0, 1, minus 1, 0. So let's take some simplest example, that is A is equal to 0, 1, minus 1, 0. So this is a 2 by 2 matrix. So what is the transpose of this matrix? So transpose would be 0 minus 1, that is 0 minus 1, and it would be 1 0. So we have find transpose of A. Let's find A inverse. A inverse is equal to 1 by AD. What is A here? A is 0. What is D? D is 0. So it would be 0 into 0, that is equal to 0. Minus would be minus. What is B here? 1. What is C here? Minus 1. That is 1 into minus 1 is minus 1. And just interchange the value of A and D. And here it would be 0, 0. And in place of 1 we will write minus 1. And in place of minus 1 we will write 1. Just simplify it, it would be 1, 0, minus 1, 1, 0. Since A transpose, here A transpose is 0, minus 1, 1, 0. And A inverse is what? 0, minus 1, 1, 0. Since we get the same matrix, here we find A transpose n is equal to 0, minus 1, 1, 0, and next we find inverse of A, that is 0, minus 1, 1, 0. Since the matrix is same, all the elements of A transpose is equal to the elements of A inverse. So A is an orthogonal matrix. So A is an orthogonal matrix. So it is easy to find for a 2 by 2 matrix. So if we have a 3 by 3 matrix, that is, if we have a 3 by 3 matrix, for example A, B, C, D, E, F, G, H, I. If we have a matrix A, B, C, D, E, F, G, H, I, for example, this is a 3 by 3 matrix. We can just simply you can just tell it by watching it, because here 3 rows, 3 columns, so it is a 3 by 3 matrix. So if we are asked to find the inverse of this matrix, we will just use this formula. That is, we will just use this formula. That is A inverse is equal to 1 by determinant of A. That is, we will first find determinant of A and we will find adjoint A, that is adjoint of a matrix A. We will find adjoint of this matrix. and we will find A inverse. And if A inverse is equal to the transpose of the matrix A, then we will say A is an orthogonal matrix. A is a orthogonal matrix. So we will use this formula for 3 by 3 matrix, and we will use this formula for 2 by 2 matrix. So that's all for today. Thank you, students.